So hello to everyone. Thanks a lot to Samsung and especially to Luc for inviting me tonight, this afternoon. I'm the co-founder of Deepomatic, and Deepomatic is a startup specialized in developing customized computer vision applications for its clients. We are a B2B startup. We are 20 in the company. We have approximately 15 clients, mainly big corporation. And today I'm happy to share a few insights about, in our daily job, how do we extract insights, how do we extract value from images and videos in concrete application of the daily life for our client. And I'd like to share a few things about we have created the company 3 years ago, and we have worked on different type of technical approach. And I wanted to share a little bit with you what we have built, what worked, and what was a little bit more difficult. So, yes, all that gives insight about how to build very effective and very performant computer vision applications. So, as I just told, we are a software editor, and our software platform allows our clients to build their own image recognition applications, from the dataset structuration, the training of deep learning models, to the deployment of the algorithms that have been produced into their own IT infrastructure or into cloud providers. To share a few examples, those images illustrate the type of applications that we develop with some clients. On the bottom left, you can see some Rust. So here the goal is to automate the maintenance of electrical infrastructure by understanding the level of corrosion of some installations. On the bottom right, it is our biggest client, actually, and the use case is to understand what is on a food tray, and if you understand exactly what has been taken by the guest at the enterprise restaurant in canteens, you can automate the billing. And it has two impacts for our client. First, it can reduce the waiting moment for the guest, and it is something very important to raise the number of people that will go to the enterprise restaurant and who will not go out to eat somewhere else. And the second thing is, of course, productivity, because you need much less cashier to do the job. Entering in some numbers, that client has more than 40,000 cashiers, so obviously it's something extremely big for this corporation in terms of impact. And this is how we see AI, a lot of different use cases that represent altogether a form of new industrial revolution, allowed by all those type of information that you can gather from the data of your installation, your restaurant, your infrastructure, your highways, to develop the new generation of services for your final customers. And the top use case is also very interesting. It's the new generation of tolls in highways. So here, the client used the platform to understand the type of vehicle that enter the highway. The class number 1 is motorbike, the number 6 is super big trucks, and you need to recognize that very simply, but also to detect the license plate, and if you want, you can connect the license plate to the credit card of the user, so you can automate the payment during the flow of the passengers going through the toll. And so this is much more easy and much more convenient than the actual automatic technology that is based off very complex laser and magnetic magnetic installation behind the road. I will come back to the latest example and to detail some things that are necessary to build an effective computer vision systems to solve those kind of problems. So this is a movies. I wanted to explain something that is illustrated by that movie. At the beginning, we were, 3 years ago, extremely excited about all the different applications that were made possible by advancement in research and development about deep learning. And we thought, okay, we should also work on those algorithms, and we should develop the next generation of deep learning algorithm that will be more effective to solve problems than competitors. And this is how we started to work in research and development. Few explanations, sorry it's quite late, but this is a neural network that automatically colors the movies. So there is a training set of black and white movies and colored movies, and when the algorithm see a new movie, it is able to color automatically the movie. So it's super impressive, the kind of things that you can see in computer vision conferences. And we started to work on research and development. So for instance, we had a problem about how to build some search engine based on image. So I want this chair, and I can just take a picture and find it in the e-commerce. This is the use case. So to do that, we started working on Siamese network. It's super interesting science, because here you have one big neural network, and the goal is you have one neural network, and the data set is made of pair of images that represent the same product, but in different situations. So on the top, you have a product like the hat, and you have the same product on the bottom images. So it's thousands or hundreds of thousands of pair of images, and you train the neural network to reduce the distance between the two images. And at the end of your work, if you trained it enough, it should be able to take a picture in the real world and to connect it magically to the product that looks like the most in different type of e-commerce. So it seems to be excellent, but actually we didn't manage to do it. And we didn't manage to do it, I think, not because we were not good enough, it was because we had not the time to work on research and development as a startup. After 6 months, we had to decide that we should stop working on it because it was a technology that was too difficult to create, industrialize, and implement. And we understood that we would need at least a few years to be able to change radically the way people work with a neural network and to create like kind of new generation. So instead of that, we started to change our way, and we started to develop a lot of different experiments. It's the world of computer vision, and especially in deep learning, is full of very interesting publications. And so instead of developing something that was above cutting edge science, we decided to test everything. So different kind of experience could be, I want to try 10 types of different frameworks of deep learning for 10 types of different problems. I want to augment artificially the quantity of data I have by doing some transformation on my data set. I want to play with meta-parameters of the neural networks and to change the strategy of training for each neural network that I test. And so we developed this methodology about testing a lot of things, and it was much more effective to give good results. So it's quite small. I should make a zoom, but here you have different type of neural network, framework like GoogleNet, AlexNet, ResNet, and other type of algorithm, logistic regression, and SVM, different type of problems, and we test for all the different type of problems, the different type of neural networks. And then we get some knowledge. Okay, for this type of problem, like quality control in factories, we should use this type of neural networks with this special type of training. And for a different kind of problem, we have our empirically, we can say that something different will work better. And this was actually much more effective. We understood that it's really an open field of research, computer vision. And especially computer vision is a world extremely open, where most of the things are published, including block of code that can be used to develop and to improve your own solutions. So finally, 1 year and a half ago, we started to implement all those tests inside our platform to allow our customer to change the parameter and to select the best way to train a model that would solve its own problem. The second feedback that we got is that actually, if you work on your own data, I mean by that if you operate highways and if you work on the images coming from the cameras that are already set up at the toll, you don't really need a lot of data to get very good results for a specific task. Not that much. For instance, when we developed the proof of concept with only 10,000 images, we were able to get 95% of accuracy on the different class of vehicle. Class number 1 motorbike, big trucks, small trucks, caravan. And so with only a little bit more than 1,000 images per class, it was already more accurate than existing solutions. That, by the way, are currently completed by humans, correcting the result when it is wrong behind the camera that you see at the toll. So the message here for all the people that want to develop specific and customized application is that somehow the difficult thing is to structure the project and to pipeline the technologies, but once you get organized, structuring the dataset for some applications can be something that is not anymore the bottleneck of artificial intelligence application development. But when you develop your system during the POC, during the proof of concept, you measure your performances on a specific validation, what we call a validation dataset, and some circumstances will appear in the real life. Like some days you will have a snow tempest, and another day a new car that is very fancy and strange will appear on the market, and your artificial intelligence that you have developed will be confused. So a system that you develop should be improved over time, all the time. It's not something I develop it, I put it in production, it works. It's something that needs to be maintained and improved continuously. For that, the methodology that is implemented in our software, but that can be used by anyone in different situations, is a loop of a kind of discussion, continuous discussion between the artificial intelligence you are developing and your experts. So basically, the first step is people annotating images, because deep learning is showing a lot of examples of each thing that you want to recognize, and then you learn on it. Once enough data is enriched, you can train your image recognition model and deploy it in production. And then on the highway, what will happen? When the system makes a mistake, or when the system is right but not really confident, all those images move up from all the different tools in France and out of France, and go back to the centralized system where they are again annotated to enrich continuously the dataset, to retrain deep learning models that are more and more effective, more and more efficient. And the deep learning models are re-implemented every week, every night, in the local system that runs the artificial intelligence at the tool. Why local, by the way? Why local? It's because when you work in the real life, in factories, in tools, you do not have sometimes the possibility to stream all the videos from the installation, from the infrastructure, to a centralized cloud. But you also need to have something that is absolutely, like the availability of your solution should be 99.999%. And you cannot do it actually if you have complex systems with applications that are based on the cloud, or it's more difficult. It's better for, so far, for our understanding, to have local doubled infrastructure to answer the query locally. And of course, if you have any failure in your artificial intelligence, you can create huge traffic jam because the service is not available and everything stay closed. So the second thing that is very critical in real artificial intelligence applications that are developed and implemented in the real world of infrastructure, factories, and so on, is deployment and engineering around the solution deployment in IT infrastructure that are very, very robust. So I think this is all. Just a last slide about actually a bit of advertising for what we are doing. To conclude, I wanted to share that our job is to build that platform that allows any enterprise to build an application, an AI application, in an end-to-end way, from the dataset management to the deployment of the solution in its own infrastructure. Thank you very much, and let's talk later.